Okay, we got one more thing to do, and it is also with a and b. All right. So a being outside the function, what if I don't change the value? I just make it the opposite. So instead of changing that 1 to a 2 or a 3 or a 1/2, I say let's make it -1. What is going to happen? So it usually affects our output. So what if I go down here and I use the negative, not the minus, and I say x squared? Well, look what happens. Instead of opening up, it opens down. So what happens right here? It opens down. What if I do the same thing in here? Alright, well, this one's going to be tough to see. And in the interest of making notes that weren't 10 pages long, we did something we probably could have done a little bit better here, but we'll talk about it enough. And this is going to become so second nature to you, it's alright. When I graph that, there's the first graph. And the truth is, the second graph is already there. So I'm going to show you what happened. If this is f of x equals x squared, right, which is this graph right here, right, what happened was this. This graph contains these points. It contains x and f of x. It contains -1, 1. It contains 0, 0. And it contains 1, 1. Well, this graph, f of x equals quantity negative x squared, looks exactly the same. What happened was this. Alright, x and f of x, when I plugged in -1, well, over here, -1 squared, right? -1 squared was just 1. Over here, -1 is now 1 squared, which is still 1, right? But it was 1 before it was squared. And what happened is the point that was here then moved over here. And the point that was here was moved over here. So this function right here, when you change your b to a negative, it reflects over the y-axis. Which, if you think about it, changing my input would do that, right? That would change a 2 to a -2. It would change a 3 to the -3. So instead of plugging in 4, I square -4. When I plug in 5, instead of squaring 5, I square -5. Sure, my output's the same, but you can kind of understand why it would be a reflection over the y-axis. So, across the x-axis, alright, so let's just do it here. Across the x-axis, see, this is the one that goes across the x-axis. Happens, alright, that is going to happen when your y changes, right? So that's going to be outside the function. And it negates, that means makes opposite, the y coordinate. Alright, across the y-axis happens inside the axis. And it negates the x, that means it makes the x the opposite. So, again, that's a little weird, but if I just drew a coordinate plane like this, and I had an x value, and then I made it the opposite, I made it a -x, look what I'm jumping over. I'm jumping over the y-axis. Let's say I had an output of 2. That's a y value. And I changed my y values, right? I'm actually going across the x-axis. Okay? So, we can now have more transformations applied to a function at a time. Use the general functions to multiply the transformations to complete this. Alright? Note, always perform transformations in the following order. Alright? There's beautiful ways to do it, but this is the way I would recommend. And I'm actually going to show you it a little bit different when we do it in class, but B happens first, then H, then A, and then K. And I'll show you that. We'll talk about that. I usually do it a little bit different, but that's the order that you'll never mess up on. Alright? And here we go. Horizontal stretch. Horizontal stretch is going to be my B value. Translate down is going to be my K value. So I have a B value of 2, so my function would look like this. F of x would equal, my A comes first, right? Let's write it right here. f of x equals a, and then I have inside the function 1 over b x minus h plus b. And we're going to write it in general terms. So this would be a b of 1. So I would say my function, b of 2, 1 over 2, and there is no h, so I'm going to just say x, and then my k is 5, so I go plus 5. Okay? Use your notes. Spend time on this. This says a horizontal compression of 2/3. Horizontal compression of 2/3. That means b is 2/3. I'm going to write this twice. Right? So horizontal compression of 2/3 would make b 2/3, and it would look like this. It would be f of x equals a function of 1 over 2/3, like that, x. But we're going to flip it because it's on the bottom. So f of x, I should be using g of x perhaps, but a function of 3/2 x. That will give me a horizontal compression of 2/3. Okay. I'm going to come down here. This one says vertical compression by a factor of 1/6. So my a is 1/6. Then it says left 1 unit. My h equals 1. We are going to practice this. Don't stress if it seems weird. So here's what we got. We'll say g of x. G of x equals 1/6. A is outside the function times the function of, remember it's counterintuitive, left would be x plus 1. And I should actually say h is -1, and we will talk about this soon. Alright. Vertical stretch. By a factor of 8, that is going to be my a. Translate 3 up, that is going to be my k. And it's going to be this. We'll say g of x. Let me rewrite that. G of x equals, my a goes first, 8, times the function of x, and then I'm going to go plus 3 because that's my k. And I am going to stop here. We are going to practice this like crazy, so don't stress out if this is at all weird. And you're going to get so used to a, b, h, and k that it's going to become so natural, because we're going to do this for a lot of functions. And I will see you guys soon.